In this video, we're going to talk about what are signals. We're going to discuss the available signals and the types of the signals available in Linux, and use kill, kill all, and a pkill to send signals from the command line, right? As we know, signals are used to emit notifications for a process to take action in response to often unpredictable events. These may be caused from within the process itself or from external events such as other processes. Many signals are fatal and resulting in process termination. However, death sometimes can be averted if the program designers decide to handle certain termination signals. Furthermore, many signals are more benign and are just informative or request other kinds of actions. It is possible to send signals, including those that induce termination from the command line using kill, kill all, and a pkill. Let's dive in. Let's start with what are signals. What are signals? Signals are one of the oldest methods of inter-process communication, IPC, and are used to notify processes about asynchronous events or exceptions. By asynchronous, we mean the signal receiving process may not expect the event to occur, expect the event, but not know when it is most likely to occur. For example, if a user decides to terminate a running program, it could send a signal to the process through the kernel to interrupt and kill the process. There are two paths by using signals are sent to a process, by which signals are sent to a process from the kernel to a user process as a result of an exception or programming error. From a user process using a system call to the kernel, which will then send it to a user process. The process sending the signal can actually be the same as the one receiving it. Signals can only be sent between processes owned by the same user or from a process owned by the super user to any process. When a process receives a signal, what it does will depend on the way the program is written. It can take specific actions coded into the program to handle the signal, or it can just respond according to system defaults. There are two signals. Sig kill is the number 9, and sig stop is number 19. This cannot be handled, and I will always terminate the program. Let's move on. Type of the signals. There are a number of different types of signals, and the particular signal sent by the kernel indicates what type of event or exception occurred. Generally, signals are used to handle two things: exceptions detected by hardware, such as an illegal memory reference; exceptions generated by environment, such as the premature death of a process from the user's terminal. To see a list of the signals in Linux, along with their numbers, do kill-l. We run kill-l. As reflected in this screen, the meaning attached to the signal type indicates what event occurred causing the signal to be sent to our process when sent from the kernel. Available signals. The signals from SIGTMIN are termed real-time signals and are relatively recent addition. They have no predefined purpose and differ in some important ways from normal signals. They can be queued up and are handled in a FIFO, first in, first out order. The meaning attached to the signal type indicates what event caused the signal to be sent when sent from the kernel, right? Well, users can explicitly send any signal type to one of their processes. The meaning attached may no longer be implied by the signal number or type, and it can be used in any way that a process desires. Again, type man 7 signal to get further documentation here. I'm gonna explain those signals one by one. For signal up, the hand up detected on controlling terminal. SIG init interrupted from keyboard. SIG quit is quit from keyboard. SIG kill illegal instruction. SIG wrap trace break point trap for debugging. SIG DTR, SIG IoT is a abnormal termination. SIG bus is a bus error. SIG FPE, floating point exception. SIG kill signal cannot be called or ignored. SIG user 1, user defined signal 1. SIG V, invalid memory reference. SIG user 2, user defined signal 2. SIG pipe, broken pipe, write to pipe with no readers. Signal RM, timer signal from alarm. SIG term, process termination. SIG STK ELF, stack fault on Mac processor. SIG child stopped or terminated. SIG count, continue if stopped. SIG stop process cannot be called or ignored. SIG STP, stop types at a TTY. SIG TTIN, background process requires TTY input. SIG TT out, background process requires TTY output. SIG URG, urgent condition on socket. SIG X CPU time limit exceeded. SIG XFSZ, file size limit exceeded. SIG VTALRM, virtual alarm clock. SIG profile alarm clock. SIG winch, window resize signal. SIG IO, SIG O, IO now, possible, right, system V. SIG power filter. SIG sys. SIG, unused, bad system call, unused signal, right? You can see it is summarized in this table. Next, kill. Since a process cannot send a signal directly to another process, it must ask the kernel to send the signal. Users, including the super user, can send signals to other processes, programs by using kill. Kill is really a bad name. Although it is used a lot to kill processes, it is really designed to send signals processes. Therefore, kill is not really accurate. The default signal sent is a SIG term number 15, which can be handled or ignored by the receiving process in order to prevent its death. It is preferable to use this signal to give the process a chance to clean up after itself. If the signal is ignored, the user can usually send a SIG kill number 9 signal, which cannot be ignored. Let's continue. Kill all and pkill. Kill all kills all processes with a given name, assuming the user has sufficient privilege. It uses a command name rather than a process ID, and it can be done as in kill all bash, kill all -9 bash, kill all SIG kill bash. Pkill sends a signal to a process using selection criteria. You can see it from the screen. You do pkill dash signal options patterns, right? dash P is PPID, dash G is GID, dash U is UID. PQ is similar to kill, but use name is instead of a PID, right? It also makes a rsyslog reread its configuration file. For example, when you do pkl -hub rsystem log d, you can see some help out here, right? Okay, that's the end of this video. Thank you for watching. I'll see you in the next one. Bye for now.